Hello guys, so I am Engineer Crehensya and I am your civil engineering buddy. Sa mga hindi pa nakakilala sa akin, isa akong full-time na firefighter sa Bureau of Fire Protection, National Capital Region. And I've been a part-time professor since 2013. And ngayon, gumagawa na ako ng mga online lectures for civil engineering subjects. Okay? So, stay tuned and I hope may matutunan tayo sa video na to. Okay, so for our first example, so yung situation is, meron tayong wall dito and ang goal is that this jet of water or yung discharge ng water will clear the wall. So, lalampas siya dun sa wall. Okay? And yung velocity na lalabas dito will be dependent dun sa height. Okay? First question pala is, meron bang effect yung diameter dito? Kapag ba mas malaki yung diameter natin, mas mabilis yung magiging velocity. Pag ba mas maliit ito, mas magiging mabilis din yung velocity. Okay? So, let's find out. Okay. So, again, what should the water level H? So, ito yung hinahanap natin. Ano tong height na to? Such that yung jet ng water will clear yung wall. So, sinabi dito, this is thin wall, so meaning negligible na yung width natin. So, first is, we need to apply yung mga formulas natin sa dynamics, no? Particularly yung sa projectile. So, meron tayong formula in solving for distance y. Medyo mahaba lang yun and I'm not sure baka magkamali ako. But basically, this solving for the distance y, for the vertical distance, with in terms of the horizontal distance x. So, consider natin to as our x distance, and this is yung y. Okay, so kung marirecall natin, y is equal to x tangent theta, then minus tama ba kakalala ko, this is g squared. So medyo mahirap talaga tandaan. Dito is 2v squared cosine squared theta. This is x squared. Kung tama yung pagkakaalala ko, no? So medyo mahirap talaga tandaan yan. Pero may mga mas madadaling formula like, so alam natin na yung velocity natin dito, yung velocity na to, vx, so this is constant, di ba? Yung horizontal velocity natin is constant. So unlike nung vertical velocity, kung eventually magkakaroon naman yan, this varies kasi meron tayong vertical acceleration which is yung gravitational acceleration. So if constant yung horizontal velocity, then the distance traveled, so which is yung x. So to solve for distance x, diba, that is x is equals to velocity, in this case along x, times time t. Okay? Then for y distance naman, so yung time na this water will reach this level, so dahil nga meron tayong downward acceleration, is equal to, so solving for y, diba, that is v initial velocity along y times time, then plus, so sa rectilinear motion, this is a 1/2 at squared. Okay? But in this case, yung acceleration natin is gravity. So, y is equal to VOY times time plus 1/2 GT squared. So, ano yung common dito sa dalawang formulas na to? So, that is yung time. So, the time it takes for this particle to travel a horizontal distance x is the same time na it will take yung particles to travel vertically at a distance y. So, yung time is equal to x over v sub x. So, kung i-combine natin ngayon itong dalawa na to, So, substitute natin yung value ng time dito sa equation na to. So, makukuha rin natin tong formula na to, no? Pero kung di mo nga matandaan, so pwede naman, ito na lang yung mga i-apply natin. Okay. So, first, initial velocity along y is 0 kasi this is horizontal. So, VOY natin will be 0. So, cancel na natin to. Okay? So, solving for y, and yung y natin is, this one's 40 cm. So, 0.4. 40 cm, 0.4 meter. Then, this is equal to gravity. So, naka-metric tayo, no? 9.81 meter per second squared. Then, yung time t over 2. I-move ko lang to. Then, yung time t is x over v sub x. So, yung v sub x natin is yung velocity na mismo dahil nga naka-horizontal din naman yung initial velocity natin. So, pwede natin alisin yung subscript na x na x na sa v. So, distance x is meron tayong 50 cm or 0.5. Okay? Then, over yung velocity. So, ito yung hinahanap natin over v. So, this is 0.5 meter. Then, quantity squared. Okay? So, gt squared over 2. Okay. So, we can now solve for the velocity v. And so, simplify natin. This will be equal to, so meron tayong 9.81 meter per second squared. And then, multiplied by 0.05 meter. Then squared, then over 2, then ibababa natin to doon, times 0.4 meter. Okay. Then yung velocity squared, so ililipat na nga natin dito, no? And since naka-square nga to, v squared, so kunin na natin yung square root. So we can solve for the velocity v. Square root of, so 9.81 times 0.5 squared, then divided by 2 times 0.4. So, yung velocity is 1.75089 meter per second. Okay. So, alam na natin yung velocity dito. Paano naman natin ma-determine yung h? So, let's consider this our point 1 and dito sa may opening, no? So, paglabas lang dun sa may opening nitong para meron siyang maiksing pipe dito sa dulo. So, let's consider this point 2. And, so, hindi naman natin alam yung diameter nito and yung property nitong opening na to. So, we cannot determine yung minor loss dito, no? And, di pa naman sinabi dun sa problem. So, we will just assume na wala tayong head loss from point 1 to point 2. So, sulat muna natin equation. So, energy at point 1 is equal to the energy at point 2. So, ano-ano ulit yung mga energy natin? So, di ba we have V1 squared over 2G plus pressure at point 1 over the unit weight, liquid, then plus Z1. Then, this should be equal to velocity sub 2 squared over 2g plus p sub 2 over gamma plus z2. Okay. So, if we set this, yung point 2 as our datum, then z2 is 0. Okay? And yung point 2, ang consider natin point 2 is yung nakalabas na dun sa may dito sa may maiksing pipe na to, no? Then, pressure at that point, so since na tayo, exposed na tayo sa atmosphere, so gauge pressure lang yung kinoconsider natin dito, no? Pagdating dito sa flow. Okay? So, this is 0 na rin. So, 0 yung pressure natin. Kasi nga, exposed na tayo sa atmosphere, so gauge pressure is 0. Okay? Then, at point 1, so, hindi natin alam gaano kalaki tong opening na to, yung surface area. And because, so we can see here na malaking difference ng area nitong opening dito sa may jet and dito sa may surface area ng water. So, although this will eventually, yung water level will drop, pero mabagal na babagal yan. So therefore, yung velocity ng point 1 is negligible. So we can just consider this as 0. So mabagal na yung pagbaba niyan as compared dito sa may velocity natin sa point 2. Okay, and since point 1 is also exposed sa atmosphere, then pressure at point 1 is also 0. Okay? So makita natin ngayon na solving for height, Z1. So yung H is also yung, technically yan na yung Z1 natin kasi ito yung ating datum. So yung point 2. Okay, so Z1 is equal to H. Okay, so Z1 is equal to V sub 2 squared over 2G. So ito lang yung kailangan natin to solve for the height H. Okay? So again, Z1 is equals to H. So solving for H, this is equal to, meron na tayong velocity, 1.75089 meter per second. Then quantity squared over 2G. And yung G is 9.81 meter per second squared. So mata natin na meter, then meter squared. So makakancel to. Then second squared, may second squared din tayo dito sa denominator, so we can cancel this. So may maiwan pa tayong isang meter na unit. So height H is, of course, in meter. So this value, then squared, then divided by 2G. And so H is 0.156 meter. Okay? So yan yung value ng H in terms of meters. Okay? So let's now proceed sa next problem. So this is actually squared. So merong tank has a hole in the bottom with a cross-sectional area. So given yung cross-sectional area niya, 0.025 meters squared. And yung dito sa may sa inlet natin, 0.0025 meters squared din. And then, so ang hinahanap is the velocity of the liquid through the inlet. So ito yung hinahanap natin. Okay, so at a certain time, the surface level in the water tank is 1 meter and rising at a rate of 0.1 centimeter per second. So this one is equal to, if we divide this by 100, no? So this is 0.001 meter per second. So yun yung rate na tumataas daw atong water level natin. Okay, so sabihin, kung i-compare natin itong dalawa, mas malaki yung pumapasok kaysa dito sa lumalabas. Okay? So, paano natin masosolve yung velocity? So, if we take this as our control volume, eto, no? Ito yung ating control volume. So, this is V out, outflow. This is definitely inflow, sinabi naman sa problem. And, since yung water level natin daw is tumataas siya, ayan. So, ito lang yung control volume natin hanggang dito. So, since tumataas siya doon, so, lumalabas tong volume na to doon sa control volume natin. Okay? So, we will consider this as also outflow din. Kasi lumalabas siya doon sa control volume eh. Okay? So, first, let's solve for the discharge. So, kailangan muna natin makuha yung discharge dito. Q in. Okay, then this is Q out. Okay, so ito yung dito muna tayo, no? So, solving for Q out. Okay, so diba kanina sa previous problem, nalaman natin na yung velocity, yung magbibigay ng velocity dito sa opening natin is nakadepende siya dun sa height. Okay, and if we, para lang mas malinaw, no? If we consider this our point 1, yung liquid surface, and let's consider this our point 2. And if we equate yung energy sa point 1 sa energy at point 2, so V1 squared over 2G plus P1 over gamma plus Z1, and this is equal to V2 squared over 2G plus pressure 2 over unit weight plus Z2. So, although nagbigay dito ng rate, no? So, kanta natin 0.001 meter per second. Tapos, i-square mo pa yan dito. So, 0.001 squared. So, mata natin na napakalit na ng value nito. So, we can neglect this. So, kung gusto mo may sama, pwede pa rin naman kasi you can still solve yung velocity. So, kaya sinabi dito, the velocity of the liquid flowing out the bottom hole is V is equals to square root of 2gh. So, nanggaling nga kasi yun dito. Pressure sa point 1 is 0 dahil exposed sa atmosphere. Then, meron tayong Z1. Then, pressure sa point 2, paglabas dun sa may pinaka-nozzle natin doon. So, exposed na yan sa atmosphere. Then, pressure 2 is 0. Then, if we set this as our datum, then Z2 is 0. So, yung velocity sa opening is Z1 times 2G is equal to V2 squared. So, solving for the velocity, that is square root. So, if we get the square root of both sides, square root of 2GH, or in this case, yung H is also yung Z1. Okay? So, nineglect na dito. So, binigay din naman tong equation na to. Kasi nga yung velocity at the surface is negligible na. So, Q out is equal to, diba Q is area times velocity. And area is 0.0025 meter squared. Then, the velocity is square root of 2gh. 2 times 9.81 meter per second squared. Then, ang h is 1 meter. Okay, so we can solve for Q out. So, 0.0025 times square root of 2g. So, nakasave na dyan yung 9.81 times 1. So, hindi ko nalagay yung 1. And so, yung Q out is 0.0110736 cubic meter per second. So, meter squared, then square root is meter. So, kaya meter cube. Okay? Then, yung Q out natin dito sa point 1, yung tinawag natin point 1 kanina. So, ganun pa rin, no? Q. So, consider ko na lang tong Q2. So, tinawag ko na naman tong point 1. This is point 2. Then, ito na lang tawagin natin Q in. Okay, so inflow. So, Q sub 2. Then, Q1, that's a liquid surface. Area times velocity. Given na yung area nito, 0.1 meter squared. Area is 0.1 meter squared. Then, velocity is, so, in this case, consider pa rin natin, no, yung kanyang velocity na 0.001 meter per second. Okay? Then, Q1 is equal to, so, 0.0001 meter cube per second. Okay? So, try lang natin na isama dito yung yung V1 squared over 2G. So, compare lang natin dito, So, yung V squared over 2G is equal to yung Z1 natin is 1 meter. Then, plus, so isama natin to, 0.001 meter per second. Then, squared over 2G. Okay? So, solving for velocity, this is the square root of 2G times 1. Then, pag ito, minultiply natin doon, magkakancel yung 2G. Then, plus 0.001 squared. Yeah, so, solving for V, natin magiging difference. Square root of 2G times 1. So, hindi ko nalagay yung 1. Then, plus 0.001 squared. So, yung velocity natin is 4.42944. Okay? So, kung wala naman tong 0.001 squared, alisin natin to. So, going back dito, velocity is square root of 2gh. So H is 1. And so 4.42944. So dito na lang nagkaroon ng difference, no? So ilang significant figures na yan? 1, 2, 3, 4, 5, 6, 7. So 7 significant figures na nagkaroon ng difference. So this is 4, 5 meter per second. So mata natin na negligible na yung negligible na talaga to. Okay? So ngayon, alam na natin yung value ng Q2 and Q1. So, sabi nga natin, these are both outflow. So, by continuity equation, so yung summation ng Q in, yung inflow, must be equal sa summation ng outflow. So, in terms of Q, again, discharge Q is area times velocity. So, area is 0.0025 meters squared times velocity in. So, yun. Again, Q is equal to area times velocity. Area times velocity. Then, equal to the summation of Q out. So, Q1, meron tayong 0.0001 cubic meter per second. Then, plus yung nakasolve natin Q2 na 0.0110736 meter cube per second. Okay? Yeah, so we can now solve for the velocity in. So yun naman ang hinahanap. So find the velocity of the liquid through the inlet. So 0.0001 then plus ito nakuha natin sagot kanina then over 0.0025. Yeah, so V in is equal to 4.469 meter per second. So, parang katulad din pala nito nakuha natin. Almost similar siya doon. So, mas malaki dapat to kasi nga, kung equal lang sila, then hindi na to tataas. Okay? Yan. Okay, so I hope nasundan natin tong example number 2. Okay, so let's proceed dito sa ating third example. So by the way, this is, yung mga kaninang problem natin, nakalagay naman yung mga source, no? So Engineering Fluid Mechanics 9th edition by Elgar, William, and Crow. So atong next problem natin is galing kay Gilasania, Fluid Mechanics and Hydraulics. So, ito yung highly recommended ko to, no, para sa mga college students. So, hindi siya ganun sobrang technical compared dun sa mga international books. Okay, so neglecting air resistance determine to what height a vertical jet of water could rise if projected with a velocity of 20 meters per second. So, kung meron tayo ditong, sige, merong nozzle, yan, tapos nagdi-discharge siya ng so, may discharge dito ng jet of water. Ayan. So, gano'ng kataas daw siya aabot? So, what is this height? H. Okay. So, ang consider natin is yung point just outside ng nozzle, no? So, if you consider this point 1, you consider this point 2. So, although na-discuss na natin kanina, ulitin ko lang, we can use yung energy equation. So, neglecting air resistance, so wala tayong magiging loss dito. Okay, so theoretical, so wala tayong magiging loss. So, V1 squared over 2G plus pressure at point 1 over unit weight plus Z1 is equal to velocity at point 2 squared over 2G plus pressure 2 over the unit weight, then plus Z2. Okay, so again, ulitin ko lang. So at point 1 and actually point 2, they are both exposed na sa atmosphere. So wala na tayong pressure dyan. Okay, and if we set this as our datum, yung level ng point 1, so Z1 is 0, then Z2 is, this is yung hinahanap nating H. Okay? So, pagdating doon sa pinakataas, so at this point, sa mata natin, dyan na yung point na from upward velocity, then ito na siya magta-transition na magiging pababa na siya, magsisimula na siyang malaglag. So, dito sa maximum height, yung velocity natin dito along the vertical is 0. Tama? Wala na. Kasi, yun na nga, mag-change siya ng direction from going vertical up to vertically downward naman yung movement. Okay? So, kita natin that yung z is just equal, yung height is just equal to the velocity squared over 2g. So, solving for z or yung h is equal to, given naman yung velocity, 20 meter per second, then squared over 2g. So, yung height is 20 squared divided by 2 times 9.81. So, yung height is 20.387 meter. Okay, so madali lang. So, I hope nasundan natin. Okay, so dito sa problem na pinakita ko sa start nitong video, medyo mas challenging ng konti lang naman. So, as long as natatandaan pa natin yung sa problems involving manometer, so madali lang to. So, air with a density of 0.0644 pound mass per cubic foot. Ano ba yung pound mass? So, normally kasi pag mass sa English units is naka-slugs. So, ano yung pound mass? Saan siya equal? Paano siya gagawing pound force? So, dito naman, yung specific weight or unit weight ng liquid inside manometer is 120 pound force per cubic foot. So, isang unit weight and isang density. So, actually, yung density ng air na 0.0644 pound mass per cubic foot, in terms of its unit weight, this is also equal to 0.0644 pound force per cubic foot. So, this is as long as yung gravitational acceleration natin is at the standard na yung G sa English is 32.2 o minsan 32.17. So, this is feet per second squared. So, ang conversion kasi natin sa pound mass to pound force is yung paano ba natin gagawing weight yung mass? Diba, kung meron tayong 1 pound mass, para maging weight to, so we need to multiply this by the gravitational acceleration, which is 32.2 feet per second squared. So, this is equal to 32.2 pound mass feet per second squared. And yung 1 pound force is equal to, ang conversion kasi natin dito is 32.2 pound mass feet per second squared. So, kung meron tayong 1 pound mass, i-multiply natin ang gravitational acceleration, so makukuha natin to, and that will be equal to 32.2 pound mass feet per second, which is equivalent pa rin sa 1 pound force. So, mata natin na parang equal lang yung pound mass sa pound force. Again, as long as the gravitational acceleration at that specific location is yung standard natin na 32.2. So, kung nasa ibang lugar na, let's say sa moon, so yung 1 pound mass will not have the same numerical value pag kinonvert natin sa pound force kasi iba na yung gravitational acceleration doon. Okay? So, we can use this as density or as unit weight. Okay? Ito yung hinahanap natin, no, yung magiging deflection ng differential manometer. So, let's start with this dito sa may duct. So, at point 1. So, again, wala pa tayo sa topic natin ng head loss. So, wala din naman binanggit sa problem. So, we will neglect yung head loss from point 1 to point 2. And since ine-neglect natin yung head loss, then energy at point 1 is equal to energy sa point 2. So, ano ulit yung energy sa point 1? So, meron tayong velocity 1 squared over 2g. Then, plus pressure sa point 1 over the unit weight ng air. So, air yung nagpo-flow dito. Okay. Then, plus Z1, then this will be equal to velocity at point 2 squared over 2G, then plus pressure sa point 2 over the unit weight ng air. Okay, then plus Z2. Okay. So, sabi dito sa problem, yung area daw, ratio between stations 1 and 2 is 0.5 or area 2 over area 1 is 0.5. Okay? So, kailangan kasi natin yung velocity at point 1 and velocity at point 2. So, solve muna natin yun. So, by continuity equation, so wala namang ibang pupuntaan yung air natin. So, Q at point 1 is equal to Q at point 2. And again, discharge Q is area times velocity. So, alam na natin yung velocity 1, given siya sa problem. So, 80 feet. So, the velocity at the inlet station 1 is 80 feet per second. So, we need to solve for V2. So, area 1 over area 2 times, so, nilipat lang naman natin tong area 2 dito sa kabilang side. Velocity 1 is 80 feet per second. And this is equal to velocity 2. So, sabi doon, area 2 over area 1 is equal to 0.5. So, therefore, pag binaligtad natin to, area 1 over area 2, this will be equal to 2. Okay? So, this is equal to 2. Then, velocity at point 2 is, so, 80 times 2. Itong ratio na to. So, this is 160 feet per second. Yan. So, velocity 2. Okay. So, meron na tayong velocity 1, velocity 2. So, Z1, so this is 10 feet. Okay? And if this is yung ating datum, if we set this as our datum. So, therefore, Z1 is, ito pala yung 0. Yan. So, this is 0. And then Z2 dito sa taas, this will be equal to 10 feet. Okay? So, solving for the difference in pressure between point 1 and point 2. So, pressure 1 over the unit weight ng air. Minus, so transpose, pasamahin natin yung air, yung pressure. Pressure 2 over the unit weight ng air. Then, this will be equal to velocity 2 squared. So, we have 160 feet per second squared over 2G is 32.2 feet per second squared. Okay? Then, transpose natin ito sa kabila. Minus, so this is 80 feet per second. Then, quantity squared over 2G. Then, plus 10 feet. And so, we can solve the difference in pressure between point 1 and point 2. Okay, so, pressure point 1 minus pressure at point 2 over unit weight ng air. So, this is equal to, so, solve muna natin to. So, meron tayong 160 squared divided by 2 divided by times 32.2. Okay, then minus 80 squared over 2G. Okay, then plus 10 feet. Okay, so this is equal to 308.137 feet. Okay, so solving for P1 minus P2, so we will multiply this by the unit weight ng tong difference ng heads natin. No? So will be multiplied by the unit weight ng air. So again, yung given na density na 0.644 pound mass per cubic foot. is pwede na nating i-equate na rin sa unit weight ng air. 0.0644 pound force per cubic foot. Okay? So, multiply natin to times 0.0644. Ayan. So, yung difference ng pressure between points 1 and point 2 is 19.844. This is pound force per square foot. Okay? So, paano naman dito sa may manometer? Okay, so kung medyo nakalimutan natin how to solve or analyze yung manometer problems, so please check na lang yung mga videos ko about that. So, ako magsasum up ako ng pressure from point 1 to point 2. So, i-copy ko lang muna tong picture para may reference tayo dito sa baba. Okay? So, again, ang density or unit weight ng liquid, ang unit weight is 120 pound force per cubic foot. Okay? So, in this case, nagbigay kasi ng unit weight ng air, no? So, pwede nating isama yung sa pag-solve ng pressure, pag-sum up ng pressure, yung unit weight ng air. So, meaning kung, sabi nga din natin, di ba, pagka bumababa tayo in a fluid or liquid, so yung pressure natin is nag-increase, and if we go up, yung pressure natin is nagde-decrease. Okay? So, pwede nating isama siya and compare natin paano kung i-neglect natin yung unit weight ng air. So, tingnan natin ano yung magiging difference ng sagot. Pag yan nahanap natin is etong delta H. So, let's say, considering the unit weight of air. So, from point 1, so meron tayong pressure sa point 1. So, ganito yung way ko ng pagsasolve ng manometer. So, in terms of pressure, so from point 1, so kung kahit hindi pa tayo dito, same pressure yan. Then, as if we go down, so by the way, lagyan natin to ng, ito, no? So, let's say this is Y. Okay? So, from this point going down at a height of Y, so, di ba ang pressure? Pressure is unit weight times height. Yun lang naman yun. Okay? And since we go down from this point, papunta rito sa level na to, so mag-increase yung ating pressure by the product ng unit weight ng air times ng height y, which is unknown. Okay? Then from this point going down sa may liquid surface, so bumaba ulit tayo, mag-increase ulit yung ating pressure. So we will add unit weight ng air. So magkakaroon ulit tayo ng change in pressure, which is equal to the unit weight ng air times nung delta H, which is unknown then. Okay? And then, nandito na tayo sa point na to. And since this is homogeneous liquid, so from this point, pwede na tayo lumipat dito sa kabila. Tama? Pwede na tayo lumipat agad dito. So, walang change in pressure dyan kasi isang liquid lang yung dinaanan natin nung bumaba tayo and umakyat tayo dito sa kabilang side. Okay. Then, from this point going up, papunta doon, hindi yata masyadong kita. Papunta dito. So, since umakyat tayo, the pressure will decrease by how much ulit? So, that's the unit weight nung liquid times delta H. Okay? And then, from this point, going up, hanggang dito lang muna. So, magde-decrease ulit yung ating pressure. So, minus. That is unit weight ng air na to ulit, no? Yung dinaanan natin na to. Unit weight ng air times same height na y. Okay? Then from this point going up to yung level ng point 2, so minus unit weight ulit ng air times nung 10 feet. Okay? So saan tayo nag-stop? Dito sa level ng point 2. So all of this will be equal to the pressure at point 2. So, we can cancel yung unit weight ng air times y. Positive tayo dito. And meron tayong minus ng unit weight ng air times y. So, same value. Isang plus, isang minus. So, we can cancel that. Okay? Pagsamahin natin yung P1 minus P2. Transpose natin ito sa kabilang side ng equation. Then, this will be equal to. So, eto unahin ko na to. So, unit weight ng air 0.0644. So, this is pound force per cubic foot multiplied by 10 feet. Okay? So, positive. So, okay na to. Okay. Bilugan ko lang na para hindi tayo malito. Then, this one, i-transpose natin sa kabilang side. So, magiging plus. Unit weight ng liquid is 120 pound force per cubic foot times delta H. Okay? And then, i-transpose din natin to. That's the unit weight ng air. So, pag transpose natin sa kabilang side, magiging minus. Unit weight ng air, 0.0644 pound force per cubic foot. Okay, multiplied by delta H. Okay? So, I guess nalipat na natin lahat. So, P1 minus P2, then na-transpose na natin itong tatlo. Okay? So, P1 minus P2, yung na-solve natin kanina is 19.844 pound force per square foot. Then, so, nandito yung dalawang unknowns natin, delta H. So, pwede palang ibalik natin to dito sa left side para magkasama din yung delta H. So, minus 0. So, times 10, so 0.644. So, pound force per, so we can cancel yung isang foot dito. So, magiging square. Per square foot. Okay, then this will be equal to 120 pound force per cubic foot minus 0.0644 pound force per cubic foot and times delta H. So we can solve for delta H. Okay? So meron tayong 19.844 minus 0.644 and then divided by, so ita-transpose natin itong nasa parenthesis na to. 120 minus 0.0644. So, yung delta H will be equal to 0.16 foot. Okay? So, that is considering yung unit weight ng air sa equation natin. So, normally, hindi nagbibigay ng, sa ganyang problem, no? Hindi na nagbibigay ng, especially dun sa, sa fluid mechanics kapag dito kasi may flow tayo ng air. So, kailangan natin i-consider talaga yung kanyang unit weight or density. But in fluid mechanics, in most cases, pagka air lang, so, disregard na natin yung kanyang unit weight. So, check natin. So, what if wala tayong, hindi na natin consider yung unit weight ng air. So, sabihin, kahit umangat or bumaba tayo along the air, so yung pressure natin will not change. Okay? So, sabihin, if the pressure at point 1 is, kung meron tayong pressure dito, which is pressure at point 1, so that is the same pressure dito. This is also P1. Okay? And kung ano man yung pressure natin dun sa, pressure natin dito sa point 2, so along the air, kahit mababa tayo dito, so this will still be equal to pressure at point 2. Okay? So again, that is yung, if we neglect yung unit weight ng air. So, how do we write the equation ng manometer? Okay? So, pwede na tayo dito kasi this is pressure 1, this is pressure 2. So, from this point going to the other side ng manometer, so pressure 1, okay? Then, if we transfer this sa kabilang side, again, that is still equal to pressure 1 kasi nga homogeneous yung liquid na dinaanan natin. When we go down, pressure increases. Go up, same height. So, pressure decreases. So, those will cancel out lang. Okay? Then, from this point going up, mababawasan yung pressure natin by how much? Okay, so mababawasan siya by the product of the unit weight ng liquid, 120 pound force per cubic foot, times nung delta H. So, saan tayo nakarating? Dito sa may point na to, na merong pressure na na P2. So, P2. So, P1 minus P2 is equal to 120 times delta H. And alam na natin yung value ng P1 and P2. Ito yun, 19.844. Then, divide natin ng 120 to solve for delta H. So, this is 0.165 foot. Okay? So, again, this is disregarding yung unit weight, yung change in pressure within the air. So, yung difference natin, minus ko ito ng, so, yung 0.0053 times ko ng 12. Tingnan ko lang in terms of inches. So, 0.06 inch, which is napakaliit. So, convert ko sa millimeters. So, only less than 2 millimeters yung difference. So, yung 0.0054 divide ko ng 0.16. So, nasa 3% yung naging discrepancy natin. Okay? Which is not much na rin. So, since given yung unit weight ng air, so ito dapat yung sagot natin. Okay? So, gamitin natin yung unit weight if it is given. Okay. So, that's it for this set of problems. So, pipilitin kong humanap ng time para makapag-create pa ako ng marami pang examples, no? Kasi medyo maraming problems sa Bernoulli's energy equation. Nagawa ko ng mga problems involving yung mga pump and turbine. Okay? So, again, if may natutunan kayo dito sa video na to, please bigyan nyo ng thumbs up and share natin para sa mga classmates nyo, and please consider subscribing. So once again, this is Engineer Crenshaw, your civil engineering buddy.